absolutely. Thank you so much. And if I would apologize first, like if I don't come to your question because I've got a lot of content, feel free to ping me on Twitter. My Twitter handle will be in the bottom of my slides anyway, so feel free to DM me. DMs are open. But before we go into actual content, we need to talk about this. And you probably, if you are in the UK, you know where this is, right? King's Cross platform 9 3/4. And you probably ask yourself, Brian, but what does this have to do with security? Well, let's get back to that movie. Let's just take the first Harry Potter movie. My platform 9 3/4 is not a real thing. You think. But if you go on that wall, like that particular wall, and you go there with your card, with the right tools, with the right amount of force, you bump into it, then ta-da, it's there, and you find stuff you could have never imagined. Funny enough, that's the same with security. You think it's not there. You think there are no problems. But if you have the right tools and you put the right amount of force on the right spot in your application, people can find out things you didn't want them to find out. So let's make sure we're don't ending up in at night platform 9 3/4, but let's try to adopt it, the security. Try to adopt security from the beginning because we are builders and we think if it works, ship it. But that's not so much the case. We have to think of it from the other way around. What if somebody accidentally stumbled up on this wall and bumped into it? Then he would be in that magic platform. And we don't want that. We don't want the malicious people to be in our application by accident. Or maybe they didn't do it by accident. Hold that thought. This is me, Brian, developer advocate for Sneak Security Company. I'm a Java champion, do a bunch of stuff in the community, but that is not important because we need to talk about security. And first of all, who is actually responsible for security? Well, we asked this in our annual State of Open Source Security survey, which brings the State of Open Source Security report. And if we specifically look at software, so the applications, and not so much as the infrastructure, because the infrastructure is a thing. Got it? I mean, we now have to do Docker containers as well. But let's keep it to the application. This was the result. 81% of the folks believe that developers need to take their fair share. And that's for a good reason, because we make the decisions how we implement our problem. Basically, what we're problem solvers, and that's a good thing. But let's make sure that if we solve a problem, we not only make it feasible, scalable, fast, readable, and making sure that other people in my team actually understand what I did, but also let's make sure that I pick the right code construction, but also the right libraries and everything right from a security perspective, because I make that decision. I have the liberty to do that. We have teams that can operate individually, but we need to take our fair share in this part of responsibilities. But I will bring you a few best practices. Let's say that, and some of these things will sound easy to you. Maybe you actually even doing that. Good for you. Then you are on the right job. Then you're doing the right thing. And I might surprise you with one or two of the things. But let's take this as our initial checklist and see if we are actually doing this. So let's first go into SQL. SQL is, well, still one of the most used forms of a database to do data storage. And when we're looking at SQL, and specifically SQL injection, we see that if we're looking at the OWASP top 10, SQL injection is still somewhere at the top. I know that it recently changed to top 10. They brought a new version. But simply, it's still one of the most easy things to do. And don't get me wrong, if you're like, hey, but I am on MongoDB or some other NoSQL thingy, SQL injection is also applicable to many of the NoSQL databases as well. But let me just give you some examples. So I'm having an application here, and what I can do is I can search by name, and I can use a wildcard. For instance, I can search by username. So, that's not what I wanted to do. Let's go back. To this one. And let's say if I do Spider-Man, I will have only this user. Okay, but what I can do as well, it says something like I can use the percent sign to use it as a wildcard. But if I didn't properly implement this well, I can do weird things like maybe I can do something like this. So with that single quote, I actually cut down the first part of my query and I just put in an or statement. And this time I search on a first name. And what I get now is that I can actually search on a first name. That's not what we want. But that's not even a big thing, right? Except if you do this. Now I just close the whole query with this, what is called the semicolon. And then I update all users and set the first name to muhahaha. Let's try this. So by doing this, I get no response back. But if you now see that everybody's got is called muhahaha. And still, if I created my tests in a good manner, we probably didn't find this because this is not a thing that you normally test, because we think from a functional perspective, from making sure that something works. And well, not so much from a security perspective. So let's take a look at the code. This is the actual code that we're executing. This is my search repository, and what we see in my search repository, find user by username, I'm having this parameter as a string. I get this in, and without doing anything, any sanitization at all, I will put it as part of my query. And one of the things we need to do is making sure that if you do an old-fashioned query statement like this, we have to make sure that the actual query and the parameters are separated. And one thing we can do that, we call this query parameterization. And one thing we can do this with is not using a statement, but is using an old school prepared statement. So let me just change this. So let's make this a prepared statement and call this statement and not create a statement. No, I think we have to change this a bit. Let's make this a prepared statement. So, and I can base this on this query, but I need to change the query as well, right? It's not like this. No, let's take that parameter out and let's make sure that it something like this. So I have a prepared statement, and then I need to insert that parameter. So I can simply set string, and I think it is at, let me just, yeah, it's at 1. 1, done. That it was the parameter. Cool. So I can execute the query, and this should be fine. So let's just rerun that application. And the interesting thing is that people say, yeah, well, what is the difference between using a parameter, a prepared statement, and using other things? Well, a prepared statement is something like, I am now making it a 2-step function. I am sending the query with the wildcard already to the database. So the database can already use that to perform a execution plan. So the execution plan is already there. And in the second step, what I do is I give it the parameter. And by giving it the parameter in the second step, it means that the execution plan is already there. So actual query parameterization, what I did earlier, isn't possible anymore. So doing things like this, and if I search again, it's not possible, you see, because all the first names are still the same. I cannot do this anymore because it's now seen as a separate thing. I separately have the query and I separately have the parameter. And by doing this well in these 2 steps, it's practically impossible to do an actual query injection. The difference if you're using other frameworks, and I think it's to say same with the Spring framework, and when you can do the CRUD repository, also use the query parameterization from there, is that they do it client side. They do it client side and say basically try to escape it and make sure that there's actually a SQL query that goes from your application towards the database. If you use a prepared statement, that is not the case. There is no such thing as a SQL, one SQL element anymore. First, you send the SQL element with the wildcard, and you leave it up to the DBMS to take care of this. So you see how important it is to make sure that you sanitize these kind of things. Because I now changed the first name, but can you imagine what happens if I'm able to change passwords and usernames? Then I'm able to override that and log in as you, and I can do all sorts of things that you don't want it to be. And this is something that we need to be aware of because, hey, tell me one enterprise application that doesn't work with a data storage. And many of these data storages are either NoSQL, and you probably can use some kind of SQL language to query that NoSQL database, or it's an actual SQL database. So Important. And you probably have heard of this. Maybe you've heard of this in school. Good for you. You went to a great university in that case. But in many universities, this is not yet taught. It's something that you need to encounter. And basically, when you filled this once, you probably think of it from that point on. So don't be that person. I had that mistake once, and I will never make that mistake again. Next, let's get into sensitive data. And think about it. What is sensitive data? It's not just your phone number or your credit card number. It's basically everything nowadays, especially with GDPR, that is related to you as a person, that can be traced back to you as a person. And what we need to do as software developers from the get go is to make sure that we implement the least privilege principle. What does this mean? Well, basically, you just want to, if I am a user, I only can do what I need to do and nothing more. Nothing less doesn't make sense because then I cannot do what I need to do, right? But just make sure that you have enough privileges to do what you need to do. Think of this. If I'm in the hospital and I'm having some sort of bad kind of disease, I want the nurse that takes care of me, I want to know that she knows what I'm having, the doctor, but I don't want the janitor in that hospital to know what I have. It's none of his business. And if it's just out there in the open, the janitor might know. He might tell it to my insurance company, and that can have dramatic effects. Luckily, there are laws in place, but let's not go into that detail. But let's get into something interesting. Say I'm having wait, don't do the code on screen. Let's do the code in real life. I'm having an API, and I'm having an API that I can show you all users in my application. And of course, this is not a real good API because one of the things it now shows us is the password. And that is something I don't want. Like the password, of course, I should have encrypted the password in some way, but that's not the point. I show the password. And what I'm doing here is I'm showing the domain object user. I'm just showing it in my API. There are a few things how you can prevent this, because this is what happens if you have domain objects and like, oh, let's make an API out of this. And now you basically show too much information that your front end maybe doesn't even need. So, okay, let's go to the code back again. It's still running. Absolutely great. What we have here? We have our API. Now let's go to our API controller. And what my API controller does, let me enlarge it. It just uses my repository and finds all users and just shows it. Well, the best thing what you can do normally is not show the domain object at all, but make a specific object like I did over here. I created a specific API user that does not contain the stuff you don't need to. That is the best thing you can do. But still, there might be stuff in it that is you need internally, but you don't want to output to the outside world. So again, remember, it is a good practice to make specific objects as a return type for your API call. I didn't in this case. I just go to user. So let's go into user. And what you see, this is my domain object, and I'm a lazy programmer. This is Java 8, so I wasn't able to use records. I was able to use Lombok. And you see a ton of annotations, and we can argue about Lombok some other day, but this is what I used. And this is a Spring Boot application. I'm also using the Jackson parser. And one of the things I can do now, if I still need this object to get out, to represent it into some sort of domain module or some sort of API, what I can do as well by just simply putting this annotation on it at JSON ignore, I am now not outputting this, not marshalling this back into JSON, so it will not end up in my API call. So let me just do this. Let me just rerun this application. And this is something that is easy to do. And you can also, if you have a domain model, make sure that some of the fields that you don't want to get out, that somebody doesn't make that mistake by accident, put these annotations in. And if I put these annotations and I go back to my API, you will see that there is no more password in my user. But there's still another problem. Okay, I can do this. I can clear up my domain model. I can make sure that it doesn't there. But one of the things it is, if I look at my logs, because it's still running, right? What you can see, let me enlarge this one so you can actually see. If you see at the bottom, you see that the user is also outputted in my log file, and that still contains the password. So you have to think about that as well. It's not just what goes out to the outside, also what is there in the log files, because if it's there in the log files, that is my single point of failure. If I am a malicious person, I go in, I'm not aiming for your application, I'm just aiming for your log files, and I still have the password of your specific user. And then you have to think of it in this way. Does your administrator actually need the password or the credit card number or this information in his log file? Maybe not. He just needs the ID to trace back what's happening, not the specific thing. So you have to take care of your toString as well. In this case, I am using Lombok, so it's quite easy. But if you are using records, you have to overwrite the toString method. But in Lombok, I can do something like this: toString.exclude. I think it was exclude, right? Yeah, exclude. And this helps me that the toString method that will be generated, it doesn't contain that password. I talked to some other person, I think a few months ago, that was at Devox Poland, and he told me like, "Hey, we're doing this in our domain model, and we are making abstractions of this. That a password is not a string, but a say uh, secret field that already has these annotations on it." That is a great way of handling this from an architectural perspective. But you get me that you need to think of this because, hey, it works fine. And maybe your front end doesn't need it. But if you're exposing this, and you might expose just an ID, but if I have that ID, a UUID or something, and I can use it in another call to go into into another API call that gives me more information, I can connect all the information together that might that might unintentionally lead to a PAI leak. Okay, we got that. So let's recap what I did. Well, return all users. Yeah, we don't want that. For instance, the address, and I can put a JSON ignore in it. Or I can make sure that we have a toString.exclude if I'm using Lombok, or you have to override your toString method. Let's go to the next part. Dependencies. Dependencies are cool. Dependencies are amazing because I don't want to write too much code. Or do you? I mean, what we do is we want to focus on what makes us valuable. And what makes us valuable, yes, that's basically our business logic. So I don't want to spend too much time on creating boilerplate things that we did a ton of times. So I'm using frameworks, libraries, or whatever helps me best. But if you look at this, if you look at your application, your WAR file or your jar file, most of the application, we'll say this, the application, most of the application is not the code you wrote. Think about it. How much of this jar is actually your code? It's probably something like this. The rest are your frameworks or libraries. So you know that libraries bring in libraries, etc. That means a ton of code that you have under your supervision and you're responsible of is not even yours. But do you actually have any idea what is happening there? What you brought in? How do you take care of that? How do you take care of your dependencies? How do you pick your dependencies? Somebody might have seen already this in a previous presentation, but I just want to reiterate this. This was a demo application we wrote some time ago in 222 lines of code. It had 5 direct dependencies. But I already told you that dependencies bring in dependencies, bring more dependencies. So how many lines of code did I actually put into production? Well, it's 54 dependencies in total. It's over 400,000 lines of code. And think about it. This is Java. So everything that is accessible from your class path can be technically loaded into memory. So even if there's no direct hit to that specific package via something else, we might still be able to target that. We can still load it into memory and have that actual vulnerability presented to you. And think about it. attackers are targeting open source because, hey, a lot of people are using this for a good reason. It doesn't mean that open source is insecure. Don't get me wrong. Open source is secure to the same extent as our own code. And if you're using open source libraries, we just have to be sure that we are updating. We're updating to the latest version and we know what we're getting into. We need to know what we're having in our application and what we inherit from that. So let me give you an example of that same thing, same application I showed you before. So we have this API thing, but let's get back to get a little bit smaller so we actually see the. What I can do, I can import things, and it says choose an XML file, but I can also import YAML files. Interesting, right? But the problem is I'm using a YAML file that is a bit, or a YAML parser that is shipped with my Spring Boot application. So what I can do, let me just scan this for a second. What I can do, I can use YAML to import new users. But what if my user YAML looks like? Normally it looks like this, and it's perfectly fine, right? I bring in a new user with a password. Again, don't store your passwords like this, but again, this is a demo application. This is perfectly fine. But what I see over here is I scan my application, and I know it's a little bit small, but one of the things over here, it says this one, and I can enlarge it, hopefully, like this. And it says, hey, I'm using SnakeYAML 1.25 that contains a denial of service. Okay, what should I be doing? Well, it says to me already here, and I'm using just IntelliJ with a plugin, well, that my company provides, but it says, hey, it's a 25, but it's already fixed in 26. Interesting. But what is the actual problem? Well, if my user YAML doesn't look like this, but is something like, do I have it here? This one. If my user YAML looks something like this, one thing you can do in YAML is you can create pointers, or you can create some sort of anchors. What I did here is I'm creating a variable lol lol1. I give it the anchor lol1, but it's actually a list of strings, right? Then I do the same. I make a variable lol2, give it an anchor lol2, but it's a list of lol1s. And I traversely did do this every single time again. So by calling lolz, it actually tries to go to lol9, which is a list of lol8, which is every single item is a list of lol7. And I call this one as a first name. If I'm doing this, and I'm calling this, that means that all these strings will be loaded into memory, and basically gives me a problem with my heap. So let's just do this. Choose the file. Where is it? Here. Examples. And it was last two. And it will take some time because now it's loading all these strings into memory and into memory. And at a certain point in time, my heap is just full. And I basically will get a memory problem. Well, we can wait for this, and we will probably see this in a second. But the point is, let me get it here. It's not yet there. It's not yet there. It takes some time. I've got a big heap, but it will give you a memory problem. It will give you a problem in with your heap. And the point is, you don't want that, because now it's just me, one user. But if there are 10,000 simultaneous users, that might become a problem. What you can do is, we now know that we just have to update this from 125 to 126. There we have it. Out of memory error. Not something we like. And that's because I basically fill up my heap with all this crap that I don't need. If I just update it to a newer version of this library, and I could do this like, hey, let's go into my POM file. Let's see where it is. I already know, have the information that I kept from 125 to 126. But this one, it's a bit different, because 125, let me see, where is my SnakeYAML? Here's SnakeYAML. It doesn't have a version because it's already provided to me by Spring Boot. So I can use the dependency management stuff to override this to 126 to make sure that it's actually, and I do this by simply doing a dependency management block and saying, I want this dependency sorry, dependencies, of course. And then I need to paste this stuff in. And I want this dependency to be version. Let me outlining is not my greatest thing, but hey, I can do version, and I can give it version 1.26. If I have this and I would rescan, you will probably see that it's not there anymore, and it doesn't have that problem anymore. So by knowing this, I can make the right movements, and I know I just need to. I don't want to update my whole Spring Boot application because that is not. I mean, it's not worth it for now yet. But I want to get rid of this problem, and just by updating to a newer version, and in this case, I know it's provided to me by Spring, so I need to know my tooling, and I know that I need to use a dependency management block, and I can do this. And yes, I know I can auto rearrange my tags, but you get what I'm saying. Let's continue. So let's remove this one so I can, next time I do this, I know what's actually happening. Management, remove that. Cool. Let's go back to the next one. So we need to know what our dependencies are and what we need to do with it. And this is just a small one. There are bigger ones. I can show you bigger ones, but that takes all day. Let's go to the next one. Input. Input is a hacker's best friend, but also a developer's worst nightmare. Because people can do more things than you could ever imagine. And what we're trying to prevent, for instance, is things like cross-site scripting. And cross-site scripting is, you might think it's, hey, yeah, but it's a front-end thing. So my front-end developers take care of that. Are you sure? I mean, if your front-end is connecting towards your application, do you actually take care of it there? But that means that still in the API, it might still happen. So we need to see all inputs from all sources as malicious. Rule 0 of preventing cross-site scripting: never insert untrusted data except in allowed locations. Well, that's very vague. But basically what we're trying to say is sanitize everything. There are two ways of cross-site scripting. Well, two major ways. We can argue, we can go deeper into that, but that's not the scope of this application or the scope of this presentation. There is reflected XSS and there's stored XSS. Well, reflected XSS is quite easy. It's a non-persistent XSS, and a stored XSS is persistent XSS. So let me tell you the difference in a nutshell. If I do something in the URL and I give and it has a parameter and I change that parameter, and because of the change of that parameter, it will automatically execute JavaScript, that is reflective XSS. Stored XSS is basically I go the other way around. In some way, by for instance, inserting a user, I make sure that the comments for that user are now stored in a database, but that database contains JavaScript instead of just plain text. And because I didn't sanitize it, next time you load that user from the database, that JavaScript will get executed. So we need to sanitize both ways. Either making sure that everything that goes in doesn't get infected for some way, but also if you are the only one that's using that database, hey, perfectly fine. But if there's some other source that uses that database as well, it's an attack factor. It's something that can harm your system. Let me show you. Well, let's get into the application again. And if what I can do over here is I can go to Batman. And what I do is over here, let me enlarge it a bit so you can see the URL. And what you see in this URL that this parameter says is Batman. So if I do something like I can insert a script over here, and then the script will get executed. That is reflective XSS. So that is a quite interesting thing, but that is just making sure that everything that comes in goes out as well. What we can do as well, if you insert a new user, so say I'm adding a new user and I say something like, and I'm putting a script in here, done. This user is added. But if I go back to the search, you will see that now I have executed this because this is a way I attack the database instead of the other way around. What we can do is we can do sanitization on this. And one thing we can do over here, let's go to my, where is my controller? Domain users. Nope, I'm looking for my user controller. Let's go into the first one. It's basically the same way what we need to do. We need to do sanitization. The first one I saw you with the URL. I get the URL here and I just output the URL here right away without doing any sanitization. What I can do, I can use, for instance, the string utils from Apache Commons to do, I think, string utils. I think it was string utils, right? And oh, wait, I have tools for that. Let's go into my tooling. Let's show you that it might have found the user controller, and it says something like cross-site scripting issue. And it tells me over here, string escape utils. That was the thing. String escape utils from Apache Commons text. And now escape HTML4. That is one of the things you can use. You can also use the OWASP encoder to do this by saying encoder, I think it is. Well, encoder dot encoder. This happens when you change your demo like overnight. Anyway, you get my point. By sanitizing the input, you can make sure that it's not JavaScript, or the JavaScript is just not plainly interpreted by your browser, but it's actually just text. And you need to take care of that from the input of the user, but also whatever goes into the database, because, hey, that is then your weak side, your weak spot of your application. Let's continue it with this because I have way more things to tell you. XML parsers. Let's go that. Well, how much time do I have left? I have about until 10 past. Have you ever heard of XML external entity injection? Probably not, but let me show you what can happen. I already showed you in my application that I can import new users, and I can use XML for that. But if I use XML for that and my XML is okay, it will look something like this, right? Inserting XML, making sure that it has a first name, last name. Well, cool. And I'm using the sex parser to do this, just a plain sex parser that goes all the way in, and nothing special. But XML external entity injection, I can do something like this. You see, instead of a comment, I'm now referring to a variable. And this variable connects to an external entity that I inserted with a doc type. And don't get me wrong, you can prevent this. However, by default, if you look at how XML parsers are used, by default, this is allowed. Doc types are allowed, external entities are allowed, and that's basically for getting in XSDs or DTDs to make sure that you can validate your XML files. But if I can access other things on my local machine, I can basically show out data that is not, well, I actually don't want it to see wanted to show that to other people. And this works because, let me go into my processor. It's basically a simple sex parser that is there, basically there from the JDK. I'm having a factory, and I'm handling all the new stuff. Nothing special. I'm not doing anything out of the ordinary. This is the default behavior. So if I go into my application and I choose that user bad I showed you with the XXC injection, I submit it. You'll see that instead of a comment, I now output the content of my passwd file, which is somewhere else and not even part of this application, but it's on my machine. More interestingly, if I go to, oh yeah, STID injection is still there. It is now part of that. It's now in the database, so everybody can see it. And that's not what I want. Maybe the passwd file is not really interesting, but can you think of property files that contain tokens or at least a connection to your database, like these things that you don't want to show to other people with external entities? If you don't do anything, this is possible. What you need to do is to make sure that some things are not happening anymore. For instance, you can alter the factory or you can alter the parser itself. And what you can do is I can set a feature that I'm not allowing external entities anymore on the factory. So what I'm doing here is, if I'm setting this specific feature, external general entities are false, by doing this, every parser that is created from this factory, or I needed to do it the other way around. Sorry. I need to do the line before, of course. Every parser that is created from this factory will now have this feature disabled. Yes, it is a feature. So defaults that are there might be interesting for hackers if you don't know about it. Like, these are defaults that you don't want to have. And I would say we need to change these parsers, but up to the point that it's changed, let's be aware that these defaults can be harmful to your application. And you might say, like, I'm not using XML at all. Hey, fair point. But if you're using XML and it means the sex parser or any of the other parsers that are available, by default, all these parsers have the same problem, and you can display or connect to files that you don't want your people or the outside world to see. Cool. Next one, because I'm running out of time. Java serialization. One of my favorites. I have a complete talk on Java serialization and the problems on that, because it's called the gift that keeps on giving, which sounds like Santa Claus, but it's not. If you are using the serialization, let's go to the basics. Serialization is basically, we're having an object, we are translating it into a byte stream, and that byte stream, we either store it, for instance, in a database or in a file, or we send it over the network to some other machine, some other application. Deserialization, exactly the other way around. Say we have a file with a serialized object, we get the byte stream again, and we transform that back into an object. Well, this is basically how you normally serialize an object. Or this is an object, a value object, that is the first few lines. And then the last few lines are how you serialize it. Well, it's nothing really important yet, but what it does, it's, instead of using the constructor or something like that, you see that in this case, the constructor sets the side effect, right? The side effect is the time. But what serialization does, it uses a lot of reflection. So it basically effectively gets the values out of the strings, in this case, the value and the side effect, and stores that in an object. And an object looks like this. The string is, in this case, hi, but because it's plain text, or I'm just using a hex editor for this, I can easily transform this into hello. So I can interfere with the objects. That's already interesting, because what kind of effect is this? But the interesting part is, Java is not using the constructor to reconstruct the objects. It's using the read object thing. And that's this one. And the read object thing, there's where things are going wrong. With the read object, it gets the stream in. It's already there. It's created. And after that point, it tries to cast it to the object that I want. But remember, that object is already in memory. What if that object that is in memory already triggers something? And there's where gadgets come in. And this is what we call a gadget. In this case, I created an object, and I overrode the read object. And yes, it's a private final void method. But what it does is, hey, one of the things it has is a runnable. By reading the object, it automatically runs this thing. So I have a side effect that is not just a value, but actually a process. And even though if this kind of object is there in your class path, and I'm able to deserialize that, and you are accepting serialized objects, I can make sure that this thing is deserialized because it's already deserialized. The object is already there in your class path, and it can be through things like your dependencies, for instance. So I can deserialize it because it's deserialized already before it gets casted to your object that you wanted. So the harm is already done before, and then you get a class cast exception. Ooh, interesting. And then you would say like, yeah, but such an object doesn't exist in my application. But are you sure? Because if you look at how a deserialization problem is, it's not so much a single object. Is we need an object that does something in the read object, and we can create other files or other objects from it, and we can create a chain of events that in the end comes into a sync gadget, what we call, and that executes code. If you don't believe me, take a look at this presentation by Ian Haken. They did it at Netflix. They searched for in their stack what kind of gadget strains that are there, and because they are using so many libraries, they found out that in this case it is 7 or 6 libraries and the JDK or the GRE. If you connect a few of these classes together, you can create such a malicious gadget chain. So what can you do? Yeah, I will skip this part because it doesn't have to be a thing, but look at the if you want to know more about serialization, look at this presentation. But what you can do, say you have to implement a serialization because, hey, you're using an abstract class that is part of your domain model for some instance. One thing you can do is override that read object and give it an exception. So if somebody calls it read object, it will not actually get read. That's one thing. But say you're depending on serialization and we actually need to use this. One of the things you can do is look into, for instance, the Apache Commons IO library that has a validating object input stream. So you basically go into the object stream and pre-read it to make sure that you only accept the classes that you want. This is one thing. There's also some native stuff in Java that you can use, like JEP 219 and JEP 415. JEP 415 is related to Java 17, that you can create filters in such a way that you just allow certain packages or certain files. But by doing this, you're allowing only the files or the objects that you want, instead of just reading it and trying and waiting for the class cast exception, because at that point it's already harmful. Again, this is a large topic. I can cover a full hour on this. I will not. Bottom line is, try to avoid Java serialization as much as possible. And if you need to do that, either use the Apache Commons IO library I showed you here, or look into how you can use object input filters that are natively in Java. Encryption and hashing. Rule 1, don't write them yourself. Really don't. Because unless you are a cryptographer, don't write them yourself. Because you probably make mistakes, and the people that are attacking you, they do that probably for a living. And you can use Java low-level encryption capabilities, or, well, what we can do also to make it easy is using libraries. But make sure that you use strong and vetted libraries for encryption. And still, I already told you about dependencies. Make sure that you scan them often to make to don't fall into the trap that they are vulnerable themselves. Basically, we need 2 ways of encryption. Normal encryption, like if I've got a credit card number, it comes into an encrypted string, and I want to make sure that I can revert back from that encrypted string to the credit card number because I actually need it. And then we have one-way encryption. And I know the cryptography community will now slap me, but you have to call it hashing. But don't just use hashing. Use a strong, vetted cryptographic hash. And what we do with a hash is every single time the same password will end up into the same hash, and you cannot go back. But if you do that again, I will have the same hash, so you can connect the hashes to see if the actual password is okay. If I do another string, it will get another hash. That is the basics of hashing. What you can do is, for instance, you can use for the 2-way encryption, you can Google Think. And this is, I think, already an outdated version. I think they're already at the newer version, 1.7, if I'm not mistaken. But this helps you already to get going with encryption instead of doing all the low-level stuff. You need to set up a few things, but then it's basically calling an encrypt and a decrypt function. This is authentication. That is authenticated encryption with its associated data. I will not go into the details of what it is, but it helps you already to get your string or your data into a byte stream and the other way around. without going fully into the low level depth of what you need to do. What you do need to know is what kind of encryption do you need and what kind of encryption template you need. But in that case, you should work with your security team to get that going and what is enough for you. For the hashing, we can look, for instance, at Spring Security. And there's Spring Security Crypto, which is already part, for instance, of the Spring Security Starter in your Spring Boot application. And you can use, I'm using bcrypt over here. You can use the bcrypt password encoder to encode the password and decode the passwords. So they already took care of that, and it's already has automatic salts implemented that hashing collisions will not happen that much. At this point, it's either bcrypt or I'm confused. Let's look at the OWASP website to see what's at this point the best. Bcrypt is one of them. Don't use PBKDF2, and certainly don't use MD5 or something like that. But be aware that most of these encoders are already there at your disposal. Last thing, logging. And logging is not so much a security thing, but it's afterwards. I mean, if something goes wrong, then you might find the problem right away if somebody reports it to you, but you will get all these questions like this. Who was exposed? How long was it there? What was the impact? Etc., etc. And most importantly, am I a victim? That is what your customers want to know. So rule of thumb is, like we say, sanitize everything, is log everything. Not the PII data, but log every behavior. And not just log it, but centralize it. I want to make sure that if you have 2 or 3 servers, you're not having to go into every single server one at a time, but make sure that you centralize that logging and it's easy accessible, and preferably also do active alerting on it. If you centralize the logging, you can maybe backtrace what happens and you can find the actual problem, or you can find out who is actually compromised so you can report that properly to the authorities. Or you can say like, hey folks, there is a leak, but nobody got harmed. That's already a bit more okay than say like everybody's data is out. That's not what you want. Next, do active alerting on it, and you can use things like the stack from Elastic or whatever there is. I'm not preferring any specific product, but if logging is in, you can look at, for instance, weird things like, hey, somebody resetted an admin password. That is something, an audit trail you want to log. Somebody called a certain IP range, which is only normally accessible from the inside, not from the outside. How did this happen? This should be logged, and you might want to active alert on that. Specific SSH connections to servers. Strings like a union in it, that request that contains the word union in it might be pointing to SQL injections. All these kind of things you want to know, but also things on high CPUs, log flat lines, or 500 errors from a specific servers. You want to actively get into that, because if something goes wrong, you want to kill it right away. And you might think like, okay, my customers cannot connect to it anymore, but you also cannot leak any more data. So you want to know it as soon as possible to make sure that it doesn't get any worse, but also that if something has happened, you can give people the proper information, how things happened, what kind of behavior happened, and if they are actually a victim or not. So log basically everything from the request at the inside to where it's actually going down your, say, microservice architecture. I think I'm exactly within time if I say we have this all covered in a cheat sheet, and you can go to the URL over here or just Google it.